Hi, and welcome back to the channel. So in this video, I want to start talking about Python logging, and in particular, this first video, which is going to be one of a few, is really going to be about the concepts. So in this video, there is no code. We're not going to do any coding. The next video or set of videos will dive into the actual code, but let's just look at the concepts first, because Python logging may seem complicated, but in fact it's not. The basics of Python logging are actually quite simple. It's just that logging can be so flexible that things can get pretty complex, right? But they don't need to be. It's just that we can make them so. So we need to take a look at those fundamental concepts. So we're going to cover many of the important concepts of logging, but not all of them by any means. Python logging is extremely flexible, and it has a lot of additional things that you can do with it when you need to. Most of the time, you don't. So here I'm going to cover what I think are the most important parts of Python logging. So the first question is, what is a logger? When we do logging, right, in Python, we use the logging library, and the main object that we use is something called a logger. So what is a logger? Well, essentially, it's just another Python object, but it takes an input. It then creates a log record, which is just another Python object. So you can think of the logger as a class that can be called. It has a method that can be called on it, and it will receive some data, that's the input, and it's going to create another object, an instance of a log record, right? Just another object. Then it's going to serialize or transform the data, some or all of the data in the log record, and then it will output it to something. If you have been using print statements in your code to do something similar, well, it's kind of the same, right? What are you doing with your print statement? You are taking some input data, you are taking a message, and then you have some variables in your code. Maybe you interpolate some of those values into the string. You send that to the print function. The print function then takes that string and then outputs it to the console. Well, a logger is essentially doing similar steps, but in a more generalized way. Now, often the serialization is to a string, and it can be a plain string. So often you'll see logs that are being emitted this way, maybe in the console, or it could be in a file, or it could be in a logging system that receives those things, but it's just a plain string. Now, a string can also be structured data. JSON is a string. So JSON data is a string. This is just a string, but it is structured data. We can output that as well from the logger. And of course, it doesn't have to be a string. It could be other objects as well. It could be like Avro or protobuf or bson. Essentially, any object that can be sent to something that's then going to receive it and then store it somewhere or do something with it. Right? Essentially, that's all the logger does. It takes some input data, and then it's going to eventually send it off somewhere else in some format. So what is in a log record? Well, there's really two kind of broad categories of data in a log record. The first one is user-provided data, data that we provide when we create a log record. When we want to create a log, then we have to provide some data. What do we provide? Well, we provide something called the log level. And the log level is simply things like debug, info, warning, error, critical, and so on. And those are actually numerical values. They just have a string representation, but they are just numbers. So debug is a 10, info is a 20, warning is 30, 40, and 50. Notice how those numbers are increasing. Debug is the lowest, critical is the highest. You can, of course, add your own if you want to. You often don't need to do so, but if you do need it, it's available. You also need to provide some message, right? It's going to be some kind of string, essentially, that you're going to provide to add to the log record. And then you can also pass in additional data, and that's usually passed in as a dictionary. So we'll come back to that exact, what that looks like in this video and mainly in the coding videos thereafter. And then the other category are system-provided data points. So think like the date and time. When was this log record created? The date and time of that. What module was it created from? And you get the path or the file name of the module. That's available too. Maybe even the line number, where, when you create a log record, when you want to create a log, you have to call a function. Essentially, you have to call a callable, and that callable exists in a module at some line number. Well, that's available in the log record if you want it. And if there's an associated exception, you'll also have available the exception info and the stack trace too. You can also get things like maybe the process ID and the thread ID, those kinds of things. And there's a lot more as well that's available. And you can just look at the Python documentation for that. But there are a lot of different things that are available that are provided by the system, not by us. We don't need to provide all that stuff. Now, of course, not all these data fields are available, all the time. Like if you don't have an exception when you're doing this logging, right? There's no attached exception. Well, there won't be an exception info, right? That kind of stuff. And all these fields, all this data is available essentially as attributes of the log record object. So that's what the log record is. It's basically a collection. It's a class, which is a collection of fields, of attributes that are user-provided attributes or system-provided attributes. That's the log record. So how does a log get created? Well, there's an explicit line of code in your app. It could be something like this, logger.warning. So you'll notice this is the level right here. Remember I said in the previous slide that we have to provide certain pieces of information. The log level is one of them. Well, here it is. It's warning in this case. Could be info, could be error, could be critical, and so on. Then we have some message, which is this string over here. And then if we want to, optionally, we can pass in extra information, which is essentially just a dictionary. So your code supplies the log level, the message, and optional extra data as the dictionary. The Python logging system fills in the rest. All those other fields I was telling you about, the Python logging system fills that in for you. Now you can also supply a message with old-style printf directives and arguments, and the logger will do the interpolation for you if it needs to. So what I mean by the old-style print directives is this thing, like %s or %f, those kinds of things. And then you have to pass in the values that are going to get interpolated as positional arguments after this initial string. You don't do the interpolation here. What happens is that you pass in this template string, essentially. You pass in the values that will need to be interpolated, and then the logger itself will do the interpolation. Now, nothing stops you from just interpolating it right here and using f strings, for example, because the logger is pretty old style. It doesn't support interpolation using, the curly braces. You have to use this percentage style. And of course, if you want to, you can still pass extra in here. Now, the reason why you don't want to do the interpolation at this stage is that the logger does not always emit the log record, and we'll see why later. There are reasons for that and configurations that we can do. So you don't want to waste the time doing the interpolation unless it's needed, which is why you basically do it this way. So this way it's deferred. You're going to wait for the logger to do the actual interpolation of the data into the string itself. And so this is what it would look like if this log got emitted. The message string would now look something like this. So again, as I said, do not do the interpolation yourself. Let the logger do it. So what's the anatomy of a logger? What is a logger? So it is a Python object that's built from a class that's in the Python logging library. The logger receives a log request. As we saw, we had logger, which was now an instance of this logger class. So some instance, I called it logger. Logger.warning, logger.info. So this is sending basically a request. This is running a method on the logger object saying we want to create a log. So it receives this log request. It then creates a log record, and we'll get to the fact that it may not actually create a log record. We'll see why. But let's say that it does. It's going to emit this log record. It's going to basically receive this request. It's going to create this log record object. It's then going to transform it, for example, serializing it into a string. And then it's going to send that to some output or target or destination, whatever you want to call it. Now, the Python logging library has many predefined targets. You can define your own, but there are a lot of them that are already available in the logging library. So, for example, we have predefined targets for streams. This is what you would use if you want to output to the console, be it the standard error, standard out, those kinds of things. You also have many predefined targets for files. And you have ways of basically saying, I want my log records to go to a specific file, or I want my log records to go to files and I want them to rotate. So as the files become larger than X amount of data, of megabytes, rotate to the next file. Only keep a history of 4. Or maybe it's time-based rotations. So this allows you to have log records that go to a file that are not going to fill up your disk. So usually that's what we do. We use rotating files. Although you can send it to a single file that's just going to keep growing and growing and growing until you purge the file yourself. But of course, there's a risk that you'll, basically eat up all your disk space with logs. There are these targets for sending emails. You can actually send logs, you do this logger.critical, and that's going to go off and, send an email to someone. It can make HTTP calls. So maybe your logger, when you emit the log record, is actually going to call an API. It's going to make an HTTP request and send data off to that. Or it could be even sockets, including UDP. You can also send directly to the Unix syslog if you want to. Or you can send it to the Windows event log if you're running on Windows. You can also use queues. And I'm not going to discuss queues too much here. Maybe I'll do a video on queues at some point. If you're interested, let me know in the comments below. But the queues is used when you have a lot of log data happening and you don't want to necessarily slow down your application because of that. Because, obviously there's I/O involved with doing logging. And so you might want to offload that to a separate thread so that you now are not blocking things because you're waiting on I/O. And there's a few more as well that are available. And those things are called the handlers. So the handlers is what is going to receive the log record, right? So remember, the logger basically creates the log record. Then it's going to send the log record to the handler. The handler is going to handle the serialization of the data or the transformation of the data. And then it's going to handle sending it to the stream, the file, the email, the socket, whatever it is. So let's look now at the handler. So logger objects can be assigned a handler, one of those that we saw, stream, file, and so on. So the handler is what will take the log record, transform it, and send it to the target. So a file handler will send the data to a file. Now, which file? That's going to be part of the configuration of the handler, right? But we don't have to write the code to write to the file. We just need to configure the file handler. A stream handler will send the data to a stream. So for example, we can configure it to send it to standard error, for example. But again, this is going to be specified by configuration. And of course, you can write your own custom handlers if you want, but that gets pretty advanced. And, more often than not, the built-in handlers in the Python logging library are sufficient for most needs. So for predefined handlers, we don't have to write code usually. We just need to configure things. So I know that sometimes people get hung up on that saying, well, what do you mean I need to configure things? Don't I need to write the file handler? No, the file handler has been already written for you. You just need to configure it. So think of how you make a connection to a database, right? You don't have to write the details of how to connect to the database. That's what the connection library does. Let's say you're using PsychoPG, for example. You're not writing the code to connect to the database, but you need to provide the configuration. You need to provide the host IP, the port number, the password, the user ID, the database you want to connect to. All that is the configuration of your connection object. Well, it's the same thing here. You're going to basically configure your file handler. Which file is it writing to? Maybe it's rotating files in some folder. Which folder? How big should the files be before they start on the next file? How many files do you want to retain in your history? If it's a stream handler, which stream do you want to send it to? If it's email, well, which email address are you going to send it to? What is the server that you're going to use? What's the SMTP server that you're going to use for that, and so on. So what about the transformation step? Remember I was telling you about this serialization or transformation step that we have. Well, those are called formatters. And you can write your own completely custom formatters, but very often we use strings, right? We format our data. We essentially serialize the data in the log record to some string. And of course, we can specify what that string is using essentially templates. So we don't need to write a custom formatter. We can just basically specify what the string formatter should look like. What does the string template look like? And that's the most common way of using the formatters, but you can write your own custom ones. And of course, you can even use a string formatter to serialize to JSON, because JSON is a string. So you can emit structured logs without resorting to a custom formatter. You just write a formatter that's a string formatter, a regular string formatter, but then you basically specify the string in such a way that once it's essentially interpolated all the data into that string, you have a JSON object. And the formatter, and this is the really critical part, the formatter is attached to the handler. The formatter is not attached to the logger. The formatter is attached to the handler. Now, why does that happen? Why do we have that? Well, let's take a look at the simple case. We have a logger, which is just an object. We send a log request to that logger, logger.warning, for example. The logger is going to create the log record with the data that we passed in, with then the additional data that it fills in, like the date and the time, the module, the exceptions if there were any, whatever else, whatever other information gets collected by the logging module. It then sends that log record to the handler. Now the handler has a formatter attached to it. So the formatting doesn't happen at the logger level. The formatting happens in the handler. The handler does the formatting, does the serialization or transformation to another Python object if that's what you want and that's what your handler is customized to do. And then it sends it off to whatever your receiver or target is, right? To your console, to a file, to a syslog server, whatever. So using a more concrete example, let's say that we have a logger and it uses the stream handler. So it's going to send it off to a stream. And I've configured the stream to be standard out. So this logger here is going to send data to the stream handler. That stream handler has been configured to send the data to standard out. But what is it going to send? Well, it's going to use the formatter. And so in the configuration, I would specify for the formatter maybe this string over here. We have ASCII time, level name, and message. And then these are just extra characters that I'm putting in to separate. Now, where do these values come from? They are attributes of the log record. And the handler, the way the logger works, it recognizes those things and it will interpolate the specific values of ASCII time, level name, and message into the string. And when we get to the code, I will show you the Python documentation. There's a whole slew of those things that are available. And you can use it however you want. You can just make that string. And obviously, as you can see here, well, I could make the contents of this look like structured JSON data. So we send, let's say, logger.info with this message, test message. We send this to the logger. The logger is going to create the log record. It's going to send that to the stream handler. The stream handler has been configured to send to standard out. So on my console, I'm going to see this output over here, which is essentially this formatter that ran on the log record and actually then generated the string. And that's what shows up in the console. Now, the thing is, we can have multiple handlers for any specific logger. So loggers can have multiple handlers and each handler has its associated formatter. And that's why we do not associate the formatter with the logger, because a logger can have multiple handlers. So the handler needs to have its own specific formatter. So why do we have that? Well, in general, this is what things could look like. You could have a logger object that has 3 different handlers, and each handler has its own formatter. So a single logger can send the same log record to multiple destinations. This is why it is structured this way. So for example, you could have a logger that's configured to have 2 handlers, one for the console and one for syslog. And when you send your logger.warning, for example, it's going to send this log record to both the console and the syslog, potentially each one having their own specific format, since the formatter is associated with the handler. And there are more complex scenarios possible, and we'll get into that a little bit later. So one of the things that we could do, for example, we could send all the logs to the console, and then we have an HTTP handler, but we are only going to send the error and critical level logs to the HTTP handler. So that's one thing that we could do with these multiple handlers, is that they don't need to run all the time. And we'll come back and take a look at how that's done. And so all this can be achieved with a single logger with multiple handlers. So you're starting to see why sometimes logging can feel complex, because it's like, well, I've got all these handlers and formatters, and no, the concept is simple. You have a logger, which has a handler, which has a formatter. If you want to, you can add multiple handlers to the same logger. And if you want to, you can have those handlers basically only send certain logs to their destination, right? So you can see that the concept doesn't get any more complicated. It's how you configure things that gets more complicated, right? The complexity has nothing to do with the handler and the formatter. That's very easy to understand. Okay, and as I mentioned, the formatter is tied to the handler, so each handler can have its own formatter. So now let's talk about filters. Filters you can think of as rules that determine whether a handler should process the log record that it receives or skip it. Remember I said that you could have a logger with 2 handlers, one for the console that sends all the log requests to the console, but you could have an HTTP handler that will only process critical and error level messages. Well, that's done using these filters. We essentially add rules to the handler saying, only handle messages that satisfy certain criteria. So the filter can be attached to the logger. So you can actually have filters that are attached to the logger in general, which means that it will apply to any handler defined on the logger, right? It will apply to all the handlers. But a filter can also be attached to a specific handler within the logger. So you could add filters to the logger and or to the handlers. And again, the concept of filtering is pretty straightforward. Where things get a little more complex is when you have different filters on the logger and on the handlers, and then it becomes like, okay, what's going on? But the complexity is not the logging, mechanism itself. It's just how we're implementing it. It's just like with classes in Python. Classes are very simple, but you can make them very complicated too, right? It's got nothing to do with how you write classes in Python. It has to do with what you're implementing. So the filters that are attached to the handler apply to that handler only. And each handler can, of course, have a different filter, just like each handler has a different, potentially, formatter. Now, there are 2 filter types. The first one, which is the one that's used, very commonly, is a filter that's based on the log level. And we'll come back to that. And then the other one is just a purely custom filter. And basically, this filter is a predicate function that will receive as one of its arguments the log record, and then you basically implement the code looking at the log record, and then you either return true or false to say yes, emit the log, or no, skip it. I don't want to actually log this particular log record. So it's a custom filter. And if you think of the filter function that you have available in Python, it's the same as that predicate function that's there, right? You have a predicate function that's going to receive the element of the iterable, and it returns true or false to decide whether it should stay around or be ejected. So the same thing happens here. Now, it's not actually a function. You actually use a class. So you have to create a class, and then you create a function. You implement a specific function within that class that is going to be your predicate function. And we'll see that in the coding videos. So remember that we have a hierarchy of log levels. So we're going to look at the log level filters. Remember this hierarchy. So the lowest one is 0, which actually means not set. That is actually defined in the logging system. And remember we have 10, 20, 30, 40, 50, which corresponds to debug info all the way up to critical. So what we can do is we can configure a logger or an individual handler, or both, to be some log level X. What it means is that that is a filter. So when you attach a configuration to a logger saying, this logger, I want it to be at level X, then if the log record level, so if you send a log into it at some level, right, what's going to happen is that it's going to make sure that the level is greater than or equal to X, and then it will process the record. Otherwise, it's going to skip it. So let me show you what I mean here. Let's say that we have this logger and I haven't defined the level at the logger level, right? I've kept it right now with nothing here. So we're only looking at the handlers. In practice, in theory, in practice, you actually have a level on the logger as well, but we'll come back to that. Let's suppose that we don't. So we have two handlers. This handler is set to level debug, and this handler here is set to level warning. And maybe this handler is the one that goes off to the console, and this one is the one that sends an email, for example. Now we do this. We say logger as an instance of this logger class, logger.info. So this is an info level, and this is the message. We send it to the logger. So the logger is going to create the log record and send it off to the handler, right? So it's going to send it off to both handlers. So let's start with the first one. Well, this handler receives that and it says, well, my filter is debug, so I need to be at debug or higher in order to process this log record. And info is indeed higher than debug, so it will process that. And so, yes, we are going to emit a log record from this handler. Now let's send the info to the second handler, right? The logger is receiving logger info. It's going to send it to the first handler. We saw that it will handle it. And it also sends it to the second handler. So when it receives that, it's going to check. Here, its level is warning. Is info greater than or equal to warning? And the answer is no. Info is less than warning. It's 20. Warning is 30. So it is not going to process that. So what happens here is that this handler is going to output the log record. This one is not. Let's look at another one. Let's say we have logger.error. Let's say we're sending an error level. Well, when we send that, the logger will send it to the handler. Its level is debug. Error is higher than debug, so it is going to output the record. When we send it to the warning one, well, error is higher than warning, so it is also going to output the log record. So you can see that this level that you set on the handler is essentially a filter saying, what do you want? So if you wanted to always pass everything, you could set it to 0, you could set it to not set, and same thing with the logger, you can set it to not set, or you can set it to something higher. And very often we do that when, let's say we're debugging, let's say we have a debug environment, we might set our logger or our handlers to be at the level debug. So any debug logs will actually show up in the console or in the file or in whatever, log system is collecting the log records. But when we put it into production, we may change the configuration and we may say, no, we only want to see warning. So we'll change the level of the logger or the handlers to, let's say, warning. And all those debug, log statements that you were seeing on your debug environment will not be shown in your production environment. So let's look at log level filters. So I showed you how we can add these level filters to the handlers, but we also add the level filter to the logger, not just the individual handlers. And again, it's the same deal. We have from 0 to 50 plus whatever, additional custom ones you may want to define. So in this case, here's how I've configured my logger. I've set my logger level to be warning. This handler here is set to debug, and this handler over here is set to warning. So if you take a look at this, what's going to happen is the logger itself is going to handle the first filtering. It's going to say, well, anything that's lower than warning, I am not going to process. I will not even send it to the handlers. So even though the handler here is saying its level is debug, it will never receive debug level log records because the logger has already filtered it out. So the effective level of this handler is in fact warning, not debug, because the warning is set right at the logger level. So let's look at an example. Let's say we send logger.info and we send that to the logger. Now the logger is set to the warning level. Where is info? Well, info is less than warning, which means that the logger is going to reject that log record. It will not even send it to the handler. So there's no record being output. And then of course the same thing with the other handler, right? Info and warning. It's not even going to receive the record because it is being blocked by the warning up here. So that also is not going to emit the record. Not because the handler rejected it, but because the logger rejected it. And if you think back to the beginning, I was saying you should not do those interpolations yourself when you have a message string. This is why. Because when you send your logger info right message, if I had interpolated data into here ahead of time, I would have incurred the cost of doing that string interpolation at the time when I'm issuing the command logger.info. By using the other syntax that I showed you and passing basically the format string here with then the values after that, what you're doing is that you're letting the logger do the interpolation. So what it's going to do is that it is, since it is in this case discounting the log request, it is not going to do the interpolation. So you've saved some time, you've saved some overhead of not doing the interpolation. So that's why the recommendation is not to do interpolation ahead of time, because you might be incurring it for no reason. Okay, let's do another one. Let's do an error this time. So we're going to send logger.error, error message. Now error is higher than warning. So it is going to be accepted by the logger and it will get sent to both handlers. And this handler is set to debug, so it will emit the log record. The second handler receives it. Its level is set to warning. Error is higher than warning, so it will also emit that log record. So you can see the interplay in those levels between the loggers and the handlers. Again, there's nothing complicated here with the concepts. What gets more complex is when you have all these different levels all over the place, then it becomes just a little bit more difficult to track, right, what's going on. But there's nothing complicated about logging. Okay, so we're not quite done yet. As I mentioned right in the beginning, the Python logging system is extremely flexible. So let's look at this concept called the root logger. When you add logging to your application, there is always a base logger called the root logger that is created. By default, when it gets created, it has no handlers. Now, if a logger has no handlers and you send a log record to it, what is it going to do? Well, you might think nothing, but not quite. We'll see exactly what that is. So how do we create this root logger? Well, we have to import the logging library, and then we just say get logger, and we just pass this with no arguments. This creates and returns the root logger. So you could have called this root logger if you wanted to. So it's going to create the logger if it doesn't already exist and return it. So what do I mean by if it already exists? Well, loggers, all loggers in the Python logging library are singleton objects. That means that you cannot create multiple instances of the same logger. I'll come back and explain why that's important to know. Okay, so we have this root logger and it hasn't been configured. We just basically created the root logger with no configuration. It has no handlers. But we do send it this info. We say, hey, logger.info. What happens? Well, there's no handlers, but Python's logging has something called a last resort logger, which is essentially this thing that you don't configure, but it has a level of warning, and it just sends the message to the console. It doesn't try to do anything else. It just sends the message to the console. And so, yeah, you still have some output. Now you can actually turn this off if you want to. And you just look at you take the logging library and you just say .last resort equals false. And yes, you'll notice when you're using the logging library that things look a little different, right, for Python naming conventions. And in part, that's because the logging, from what I understand, was inspired by the log4j. That was Java. So yeah, I don't quite get it, but they used the Java style camel casing instead of the snake case that we usually use in Python. But the logging library was created a long time ago. Okay, so we can turn it off. Now, if we turn that off, the message will not be sent to the console, but it's still not going to error out. What's going to happen is that it's going to send a static message. No handlers could be found for the logger root. That will be sent out to the console. So if ever you see this as you're running your program and you see something like this, or you see some weird message where it's just the message, but there's no time, there's no other information, you got to think that I'm sending my message to my log request to the root logger, and the root logger has not been configured, right? But it's not going to stop your program from running. It's not going to fail, right? You're not going to get an exception. So these are the concepts, right? We've got the logger, we've got the handlers, we've got the formatters, we've got the filters. We saw we can add multiple handlers to a particular logger. We saw we had the root logger. So how do we configure the loggers? Well, it is possible to configure loggers using code. So you can create the logger, just like we saw just now, and then you can create handler objects and formatter objects. You can add the formatter to a handler. The handlers have methods where you can add a formatter to them. You can add handlers to the logger object. So you can actually use Python code to do all that. This is what I would term imperative declaration of formatting, right? But you also have another way that's much more common, and that's to use a dictionary, essentially. And this is what is termed to be a declarative configuration. So the config does not create the logger. The configuration dictionary just configures the loggers when they get created, but it doesn't create the logger itself. We'll see that in the code. It's actually quite straightforward. But when the logger is created, it is going to get configured automatically based on the settings in the dictionary. Now, one thing that's very common, now you'll see some people actually use a Python dictionary, an actual Python dictionary, to set up the configuration for the logging system. But very often what we use instead are external files, like a JSON file or a YAML file, because those things can be deserialized into Python dictionaries. And it's easier usually, especially in CI/CD cases, where you're going to have different JSON or YAML files depending on the environment, right? If you're in production, you're going to configure your logging a little bit differently than if you're in, let's say, your dev environment or maybe your local environment. You're going to configure things differently. Having the configuration being part of the code, that's not great for that. So instead, we have these separate configuration files that are JSON or YAML, and we just specify the configuration in there, and then those files can be different for each environment. So the configs are often done that way. Now there are other more advanced ways to provide logger configurations. You know, as I said, it's a very flexible system. You can have config servers, so you can actually have your loggers essentially listen for configuration changes that are going to come through, let's say, a configuration server. Essentially, it's going to listen on a socket, and configuration change came through. You can now, automatically change the configuration of your logging system. Maybe it's going to go from debug to critical, let's say, for your level, right? Those kinds of things. I'm not going to get into that here. That's quite a bit more advanced, and that's really just, a setup and understanding that little extra step. Okay, so I've been talking about the root logger, I've been talking about configuring loggers, and I've been using the plural term, configuring loggers. Why is that? Why not just configuring the logger? Well, that's because a Python app may have multiple loggers, each configured differently, right? So again, The concepts are very straightforward. The logger creates the log record, sends it to the handler, which has a formatter that then sends it out somewhere else. The logger can have multiple handlers. The handlers in the loggers can have filters. We have a root logger, and we can create as many other instances of log, the logger class as we want. So what happens is that we can define multiple loggers in our application, and your code can then select which logger it's going to send the log message to. So how do we create these loggers? Well, we create them by name. When we did the root logger just now, we didn't pass any arguments. There was no name. That by default will essentially get you the root logger. But you can put string in there, and that string can be the name of the logger, and it can be anything you want. You can make it whatever you want it to be. So you can say logging.getLogger, my first logger, or my second logger. I can have those two loggers created in my application, and at any point in time, I can send, an info or an error or a warning to any of those two loggers, right? It's up to you. This is the code that you're writing. So by default, those loggers are created with some default configuration. Amongst other things, that default configuration has no handlers. So if I send, and this is not like the root, right? The root logger behaves a little differently when you have no handlers. It, emits still something to the console at the warning level by default, or, that last result I was telling you about, or you can even turn that off. But when you have these named loggers, then it will create them with no handlers. If you send a log request to one of these loggers that has no handlers, it will not emit anything. It's just going to be as if you had sent that message kind of into a black hole, but not quite. So if the config for, let's say, my first logger and my second logger, if that is specified in the config dictionary, and I'm only going to talk about doing configuration using dictionaries. I'm not going to talk about, you could say logging, first logger equals logging.getLogger, then create the handler, create the formatter, add the formatter to the handler, add the handler to my first logger, and then do that, right? That's the imperative style. You could certainly do that, but I'm going to stick to the config dictionary, which also, of course, can be in a file, JSON or YAML. So if it finds my first logger configured in the dictionary, then when it creates this logger here with the get logger, it will configure it according to what you set, right? And that configuration is going to contain things like which handler do we want to use from the built-in handlers, or if you've created your own custom ones, which custom one. But generally, it's going to be a file handler, it's going to be a stream handler, whatever it is, and other configuration related to that, including the formatters, right? All that is going to be in this configuration dictionary. Now, I've mentioned this before when I talked about creating the root logger. Logger instances are singleton objects. So think about that, what it means. It means that when I call logging.getLogger my first logger, it creates this logger called my first logger. If I call this again, logging.getLogger my first logger, it doesn't matter if it's in a different module, it will still get the same object. It's not going to create a new one. It's going to find the existing one that was already created and use that one. And so when you see code where people create loggers and they start passing a reference to the logger they created around to other places in their code base, that's totally unnecessary. That's because they don't understand that loggers are singleton objects. Because they're singleton objects, you don't need to store a reference to my first logger and then pass it around to your second module so it can use that. Your second module can just say logging.getLogger my first logger, same name, it will get the same object, right? So that's very important and critical to understand. So here's what I mean. In module 1, let's say, we import logging and then we create this logger called logger A. And then in module 2, we do exactly the same thing. We say logger, get logger, logger A. The name is the same. And because the name is the same, it is the exact same object. If you were to do an identity comparison, between the two loggers, you would get true. So this logger is this logger would be true. Now, we can create multiple loggers. We've got this root logger. There is in fact a logger hierarchy that we have available. So they form a hierarchy, they form a tree. Essentially, loggers are organized in a tree structure. The root logger is always the topmost logger. And the tree hierarchy is actually determined by the logger names. And it is based on having dots in those names. It's dot notation. I've got a logger that is going to be the root logger. That is always going to exist. And then at some point, I create a logger called services. I'm going to do a get logger with the string services. That is going to create a new logger singleton object. And it is essentially going to be below the root. The root is the ancestor of everything. Now I create another logger. And I'm going to call it, let's say, models. So get logger models. It's going to create another singleton object, singleton logger. And that is also going to be under the root. But now I create another logger, and the string that I pass it is services.aws. Well, because services was also a logger, this services.aws is essentially below the services in this tree. Now, this is not inheritance, right? This is not really inheritance. It is basically just saying that services.aws is a child of services, but not in the inheritance sense. If I create another logger with the name services.db, well, that is going to be a child of services because it's services.db. I can go further. I can create one called services.db.pgdb. So this one is going to be under services.db, which is under services, which is under root. So that's what I mean by forming this tree hierarchy. You may have another one called services.db.redis. And so those things are just created this way with the strings, right? So services.db.redis, that's all it is. And because of the name and the dots that we're using, the logging system kind of organizes them in this tree as follows. So the names of the loggers are used to determine this hierarchy. Now, does that remind you of namespaces? You can have a module called services. Under that, you could have another module called AWS. What will its fully qualified namespace be? Services.aws, right under the root of your application. If I've got another module called DB under services, what will its namespace name be? It will be services.db and so on. So this should really remind you of namespaces. And it's kind of the same way how your modules are organized into this tree hierarchy. Your loggers are also organized in this tree hierarchy based on the names. Your packages and modules in Python are organized into a tree hierarchy based on names as well, right? Folders are names and modules are names. So that's all it is. Now, why is that important? Well, because of something called log propagation. So we have this hierarchy of loggers. So when we send a log request to one of those loggers, let's go back and take a look. Because I could be, let's say, in my module, and maybe my module mimics the names that I have for my loggers. So I've got a services folder. Under that, I've got a DB folder. And under that, I've got a PGDB module. Right? So I've got two modules, services, DB, and then the third one, the root one, is PGDB, or the leaf one, I should say, is PGDB. And in that module, I say logger equals get logger services.db.redis, or PGDB. So let's say I'm in the Redis one, right? So now I've got code here that's interacting with a Redis database. I want to log something. I'm going to log it to this logger, to the Redis logger, and it might be configured in a specific way. Right? And if I'm in the PGDB, I'm going to get a reference to the PGDB logger and log to that logger. Now, you don't have to. You could create a logger that's going to be for your app and then just use that one all the time. You could say logging.getLogger my app and then use that everywhere in all your modules. You can do that as well. We'll see that in the code. But so why have this hierarchy of loggers? Well, when you send a log request to some logger, If the log level and the filter allow it, the log record is produced by the logger, right? We've seen that before. That's not new. Now, what happens after that logger is done? It's performed its work, right? So the logger basically allows the log record to come in. Basically, it's going to process it because the filter, if any, and the level allows it. So it's going to create this log record. It's going to send it off to all the handlers, if any, right? You don't have to have handlers on the logger. But once it's done, sending it to all the handlers, which could be 0, what happens after that? What does it do? Well, it sends the log record to the parent, right? It decides, should I send this log record to the parent? So again, just looking at this hierarchy that we have here, if I'm in the services DB logger and I send, let's say, an info to services DB logger, once it's done handling it and it's done, it's accepted it, right? The log level at the logger level didn't filter it out and the filter didn't filter it out. What should it do with it? Well, it will potentially send it to the services logger. Okay? So let's continue. And the answer is it will do so if the propagation is turned on. So this is just another property of the loggers. So this is a property of the logger, and we can of course set that up in our configuration of the loggers to propagate up. And if that's set to true or yes or whatever, it will handle the log record and send it up the chain. And so the propagation is a configuration setting for the logger, not for the handlers, right? That's at the logger level. The default is true. So if you do not provide a specific configuration for a logger and you create a logger with a name that's not configured, it will automatically have no handlers, which means it's not going to do anything, but its propagation is true, which means that it will send the log record as long as it passes the default level. It will basically create the log record, do nothing with it on that particular logger, and then send it up to the parent, which will then in turn do whatever it needs to do. And then if it's set to propagate, we'll send it back up the chain as well. And that can propagate back all the way to the root logger. Now, what's very, very important to understand, once a log record has been created, which means that the logger to which you send the record, the data to, right, it has a level and potentially a filter. If it accepts your thing, so let's say its level is set to warning and you send an error, that is okay. The log record is going to get created by that particular logger. And let's say that logger is set to propagate up. It will send it up one level, right, to the parent logger. It doesn't matter what level of filters are on that parent logger. It will not try and filter out that log record. Once the log record itself object is created, it will propagate up all the way to the top, depending on whether those loggers are set to propagate up. So again, these are things that we're going to experiment with when we look at the code. So the question is, why would we want to propagate logs at all? As you can see, things are getting fairly complex now. We've got a lot of moving parts, right? You don't have to use all this complexity. You can use very simple configuration, very simple logging. But if you need this complexity for some reason, it's available. So what might be one reason why we want to propagate logs? Well, let's say that you have this application over here, right? So some very simple application. We have a main, then we have a services module, and then we have two submodules. We've got microservice 1, microservice 2. Okay, so that's our code. And at some point, I'm going to create this services module. So I'm going to get logger for services. I could also get logger for the services.microsvc1. And I could get one for microsvc2. So all these have created loggers. Services, services microsvc1, services microsvc2. Do you notice something? And this is why I was asking you earlier to see the kind of the parallel between the names of the loggers and your namespace conventions or your namespace names. If you look at the name of this module, if you're inside this module and you look at the name of the module, what is it going to be? It's going to be services.microsvc1. Inside here, it's going to be services.microsvc2. So what you'll see a lot of people do is that to get a handle to the logger in that module, so if I'm going to want to log things in this module, I could choose to set my, you're going to set a global variable usually in your module to be logger equals, and then whichever logger you want. And remember, it's just the name, right, that decides which one you want to get. Now, one thing to note, you usually never send directly to the root logger. You just don't. We'll see that we're going to configure the root logger to actually have handlers and so on, but we never send to the root logger itself. The best practice is to send to a named logger. So I could have a single logger for services, and then inside microservice 1, I'm going to say logger equals get logger services. Inside here, get logger services, and then use the logging to the services logger on each of those. Or, this is very common, you can do it by name. So inside microservice 1, I'm going to get logger, essentially services microservice 1, and I'm going to send my log to that particular thing. So what I can do then in terms of the configuration, I can configure the root, right? The root logger. Its level is going to be debug, and I'm going to set debug everywhere just to keep things simple for now. And the root logger is going to have a single handler. Let's say that that handler is going to send data out to the console. Now what I can do is I can have these other ones as well. Services, services micro svc1, services micro svc2. Its level is going to be debug, and I'm going to set the propagate to true on each one. Now, when you don't configure a logger, the propagate default is true. So you actually don't need to specify all this, but we'll get to that. So what happens when I send, let's say, a debug log to services.microsvc2? So in microsvc2, I said get logger name. And I say logger.debug. So it's going to send it to the services microsvc2 logger. What's going to happen? Well, it has no handlers. So it has no output, right? Now, the logger itself accepted the message because its level is debug, and I sent a debug, and there are no additional filters. So the the log record was created. But there's no output because there are no handlers. It's not defined to send the data out anywhere. However, propagate is true. So it propagates up to the parent. What's the parent? The parent is services. Now, services, its level is debug, but that doesn't matter because at this point we're already propagating. Services does not have a handler. So no handlers, no output. However, its propagate property is true. So it's going to propagate up to what? To the root handler, or to the root logger. Now the root logger is going to handle it, right? Again, it's not going to do any filtering because it's already doing the propagation, right? But it is going to handle it, and it's going to send that to the console. Now, what's interesting, of course, is that in your formatter for this handler, you can include the name of the logger. That's what that name was that I think I showed you earlier. And so by the time it reaches the root handler, it's going to output your log record with the name services micro svc2, and then whatever else it's supposed to do with the data you send in. So this is why we often use something like this, because this tells us immediately which module we were in. Now, you don't have to use it that way. You do have the module available as one of the properties on the log record, but very often it's used this way as well, so that you essentially set up one logger per module, and then you basically let everything propagate back up to the root to actually do the emitting of a log record somewhere. But again, you can configure things very differently however you want to do it. Now, what happens if I want to turn off all logging in services and submodules of services? Well, all I need to do is I need to set my propagation to false. So if I send a debug to microservice 2, it's going to handle it. There are no handlers, so no output, but it propagates up to services, and services has no handlers, so it's not going to emit anything, but its propagate is now false. That's it. You've essentially kind of quashed sending out a log record. It is not going to get sent to the root. So just using configuration, you can change how things are getting logged. And this is very useful because on different environments, you may want to have different things. If you're, let's say, on your local environment, you may want to see all your service logs, right? Not just, error and or warning and above. You want to see the debug logs and you want to see everything. Well, you can just set up your root handler and then just let it be. But now in production, you don't want to see any of the service logs. Not even, the errors and criticals. You're just not interested for some reason. I'm not sure why not, but let's say that's the case, right? You can have situations like that. Well, all you need to do is just turn off propagate on this top level one because there's no handlers, so nothing's going to happen, and then it will stop propagating at that point. So a common pattern, and this applies now to setting up logging for your apps, not libraries. What you do for libraries is slightly different because you really don't want to muck around too much with logging in libraries because you want the user of your library to configure the logging to be what they want. So I'm not going to discuss that. I'm going to discuss what we're here for, which is adding logging to our applications. So the way that's done most often is we configure the root logger to emit our logs to one or more, destinations via one or more handlers. So maybe we're going to emit to the console and we're going to emit to syslog, for example. But we do not log to the root logger directly. We use named loggers. That's best practice. If you log to the root logger, let's say that it's using this kind of formatting here with the name of the logger, well, you're going to see root in here. That's not very useful. That doesn't tell you where this log record actually came from. Was it in the main module? Where was it, right? So that's not very meaningful. You can also run into issues if you're commingling in a centralized log system. Maybe you've got different things that are sending in, log records to the same location and they're all called root. Well, that's also not a good idea, right? So it's usually not a good idea to send to the root logger. And there are other reasons as well. So in general, we don't. We use named loggers. And as I mentioned, we have different possibilities. We could use a single named logger for all logging in our application. Very simple and straightforward way to do things. We could use named loggers for sections of our applications. Like, for example, you saw I had services, and then I had for services microservice 1, microservice 2. Maybe I just have services, and everything under services is going to use the services logger. Everything under the, models, let's say, module is going to use the models logger. Everything under the API, if you have an API module, whatever it is, and you can section off basically chunks of your application into these loggers. Or you can do one for each module. And of course, you'll get then this hierarchy where, a submodule of a module will still show up as that submodule because it will flow up right with the propagation, as long as you set propagation, as long as you don't turn off propagation. And so you can say get logger name. That's another very common pattern that you'll see. But don't go overboard with it. I think doing a logger, an individual logger at each module level is already starting to get a little much. I certainly have seen people do it, and it's fine, it's okay. But you have to understand that your logger objects are singleton objects, which means that once you create a logger, you will only ever create it once, but it is going to stick around for the entire duration of the lifetime of your application runtime. So if your application is creating, 10,000 loggers because it has 10,000 modules, you've got 10,000 objects in memory that are just going to stick around the entire time. So that's why I'm saying be careful, because you do have essentially memory overhead every time you create a logger because of the fact that it's this singleton object. So don't go overboard. I've seen some people where they'll actually create multiple loggers within the same module because they think that, oh, I want to get even more granular. I think that's way too much. Again, of course, your particular use case may be different, but I wouldn't recommend that. So in terms of sections, you might have a package in your app for handling all communications to some external API, and you have a single logger for that. But if you use this get name, well, if that package has consists of the top level package and 20 nested package modules, well, do you really need a logger for each of those 20 modules, or just for the entire lot called external API or whatever you're going to call it, right? So that's what I mean by don't go overboard. Think about it. Don't just use this blindly, even though it is a very common pattern. Now, another thing that we really need to think about, and this is really critical. It is really, really, really important, okay? You need to treat your logs as if they are going to be public. Think about your Git repo. Would you store your password or your tokens or your secret keys, right? Your authentication, credentials inside your Git repo that you then push up to GitHub, even if it's private? Would you do that? Do you want other team members to see your password? No, you would never do that, right? You're not going to put sensitive information into your Git repo because it is basically public. Even though it could be a private repo, it's essentially, you could consider that as a public repo. So if you don't do that, why would you write passwords out to the log files? Those log files are going to sit somewhere and they're going to be accessible by other people. Maybe not external to your enterprise or organization, but it's going to be visible to other people. Should they really be able to see that data, that sensitive data? And the answer is no, they should not. So you should never log sensitive information. And it's not just password. It's authentication, credentials, yes, but personally identifiable information, financial info, medical info, all that stuff. None of that belongs in logs. I'll repeat. Do not log sensitive information to your logs. Do not. And many companies have been bitten by this because somebody just messed up and forgot about this. So Twitter, now called X, and I've got the links. You can go and see the stories of how basically they leaked sensitive information because of logging, right? So X did it. Facebook did it, right? Big companies with, good engineers that should know better. Stuff like this happens. You need to be really, really careful. So what else, some of the things, well, you can basically either not show it at all. So you can completely redact it. You could mask it. You could do partial masks. Let's say it's a credit card number. Maybe you just put in the last 4 digits or something. You can do tokenization so that you replace, let's say it's a password or a key, but you need to know how many characters are in it. Well, you can tokenize it. Just replace that with 15, stars, for example, or whatever it is to do. So, be careful with that and replace the data that's going to be sensitive. Now, you do have to be careful because when you're using third-party libraries, you don't know what they're logging, right? So maybe you're using a third-party requests library and you're logging all your HTTP requests that are coming into your REST API. You've just created this fast API and then you have some library that you're using, and it is logging everything to the logs, including the headers, including the request, data and all that stuff. Well, that could contain sensitive information. The header can contain the API token. You do not want that in the logs. The request might have been a request to change somebody's password on their account. Well, guess what? If you're logging the request data into your logs, you've just logged the person's new password in there, right? And it's all in clear text. So you have to be extra careful. Do not just think about your own logs that you're generating, but if you're turning logs on for a third-party library which does logging, be careful with that. All right, be extremely vigilant. All right, so that's it for the concepts. I hope that you now understand, conceptually, Python logging. It is not complicated. The basic principles are not complicated. Where things get complex is because you have so much flexibility, right? Multiple loggers, a hierarchy of loggers, multiple handlers per logger, filters at the logger level, at the handler level, level filters at the logger level, at the handler level, and so on, right? But each individual concept is pretty straightforward. And in the code video, I'll show you a very easy way to get started with logging. Just, a small config dictionary and a couple of lines of code to get your logger, and you're off to the races, and that could be perfectly fine for your application. But as your application grows, gets more complex, maybe you need more complexity in your loggers as well. The nice thing is that you could start with something simple. You can say, I'm going to have a logger. I'm going to let my root logger just log to the console. 3 months from now, you decide that, you know what, I need to send this to a rotating file. No problem. You don't have to change any code. You change your configuration. You add another handler in there that's going to send it to a file. And then maybe 3 months later, somebody tells you, hey, you really need to send it off. We want to collect that in some other system or in syslog. You need to send it to syslog. Okay, just add another handler in the configuration. And now your root handler is sending the same log record to 3 different places, right? So it's very simple to start easy with Python logging, but it's so flexible and very easy to grow it to more complex problems. All right, thanks for watching, and I'll see you in the next video for the coding.